So let's look at this problem. So here you're asked for, you're shooting a shell up and you're looking for when the fuse ignites it right at the top, maximum height. And we are trying to find the height of that and how long it takes to get there. Now, I will stress that there are multiple ways of doing this problem, okay? And arguably you could do A or B in either order. I'm just going to do this in order and how I think you should do it. Feel free to, as long as you get the right answer and you know what you're doing, it shouldn't matter. Okay? So, over here, let's look at this. So maximum height, at the maximum height, so let's think about what happens in free fall if I throw something up. Because really, the y direction is just going up. So at the top, the velocity of whatever projectile you have has to be 0. Okay? So that's the crux of this problem. So we know that Vy is 0. We then obviously need to know what the initial velocity is in each component. So we're going to have to find two components. The initial V0x and V0y. And V0x here, I have over here the V0, we know is 70.0 meters per second. So therefore, over here, it's 70.0, and this will be a cosine 75 degrees. And if I have that, I would have 18.1 meters per second. In the y direction, similarly, is 70.0 sine 75 degrees. This is opposite, right? This is going up. So here, this would be 67.6 meters per second. So now I need to solve this. I've got V0y, the initial velocity in the y direction, which is 67.6 meters per second. The final y velocity, which is 0 meters per second. Okay, I don't know what time it is. I don't know what height it is. Okay. Over here. Okay, let's think about what else we know. We know that the acceleration in the y direction is going to be minus 9.81 meters per second squared. So if we do this, think about this. Okay. We have an equation that works from constant acceleration perspective, which is y is equal to y0. So actually, it's not one of that, it starts with that. It's actually, think about it, Vy squared is V0y squared plus 2ay times y minus y0. Okay. Now we do know that y0 is 0 because we're going to define that as my initial point. So here, Vy is 0 squared. This is 67.6 meters per second squared plus 2 times minus 9.81 meters per second squared. And then y minus y0, I'm trying to find y minus 0. Okay? So if I solve this equation, I find that y is 233 meters. So that's part A. Part B, let's think about how we'll do part B. Part B, okay, again, I know that Vy has to be 0 meters per second. I know V0, 0y is 67.6 meters per second. And ay is minus 9.81 meters per second squared. And this time I want t. And here, the equation that's best suited, in my opinion, is the one that uses this information. So Vy is equal to V0y plus ay times t. So here, this is 67 point. So we know this is 0 meters per second. This is 67.6 meters per second plus minus 9.81 meters per second squared times t. And if I solve for this, I find that t is 6.90 seconds once I solve this equation out. So again, the crux is just take a component that is most suitable and then try and plug it back in. So C was a horizontal displacement. How far does it go horizontally before the shell explodes? Well, let's think about it. Horizontal movement, we're going to assume no air resistance. So this is a constant velocity situation. So the distance traveled in the x direction, so x is equal to x naught plus the velocity in the x direction times time. So this is 0 plus vx subscript x. In x direction, it is 18.1 meters per second times the time, which is 6.90 seconds, which we found from up here. So when I do this, I see that this is 125 meters. Okay,